You walk outside, you look at the morning commute, and you see Toyota cars absolutely everywhere.
Yeah, they're literally everywhere you look.
Right. We're talking about millions of electrified vehicles on the road right now. And yet, if you look under the hood of the vast majority of them, you are still going to find a gasoline engine.
You are.
Which just raises this massive question for you as a listener, right?
Yeah.
How could the biggest, most successful automaker on the planet seemingly fail to understand where the world is going? I mean, it really feels like they're just stubbornly refusing to get with the program.
Well, that is exactly how it looks to a lot of people, especially, and if you were sitting in the tech industry, it looks like this monumental blind spot.
Oh, for sure.
But to really grasp what is happening in the automotive industry right now, we need to completely reframe what we are looking at. That gasoline engine sitting under the hood of a brand new hybrid is not a failure to understand the electric future. It's actually a highly calculated, multi-billion-dollar bet.
Wait, a bet on what exactly?
Yeah, Toyota is not betting against electric cars. They're betting against uniformity.
Betting against uniformity. Unpack that for a second, because it's an interesting phrase.
Yeah, so they're operating on the conviction that the world will indeed electrify, but it absolutely will not happen through one single type of vehicle or, one universal battery chemistry.
Right.
Or one upgraded power grid, or even on one unified global timetable. The transition is going to be incredibly fractured.
So our mission today is to figure out what that fractured transition actually means for the market and, honestly, for you listening to this. We need to determine if Toyota's outright refusal to go all in on battery electric vehicles is the smartest capital allocation strategy in the entire auto industry, or if it is just a fatal hesitation that is going to hand the keys to the future over to competitors like Tesla and BYD.
Exactly.
And we're going to connect this massive corporate strategy directly to you, to your car payment, your monthly electricity bill, to the rapidly shifting balance of global industrial power.
Because the core argument here is not actually about whether electric motors work. I mean, we know they work beautifully. The real argument is about who ultimately pays when an entire global transportation system undergoes a massive infrastructure change.
So how does Toyota look at that cost?
To understand their hesitation, you have to start by looking at two very different drivers. First, just imagine a homeowner in a wealthy suburb.
Okay.
They have a two-car garage. They pull in at 6 p.m., they plug the car into a dedicated charger, and it charges overnight on cheap, off-peak electricity rates.
Yeah, and for that person, a pure battery electric vehicle is the obvious, completely logical choice.
Totally. It is quiet, it's responsive, and it is incredibly cheap to run on a daily basis.
Sure, that works flawlessly for this suburban homeowner.
Mm-hmm.
But what happens when you try to apply that exact same logic to, say, a renter in a massive high-rise apartment complex?
It falls apart.
Right, because they rely on shared street parking.
Mm-hmm.
There is no reliable, dedicated charger anywhere near their building. So when that renter goes out to buy a fully electric vehicle, they aren't just buying a car anymore, are they?
Not at all. And this is the exact friction point Toyota is obsessed with. When you buy an internal combustion car, you are buying a standalone machine. But when you buy a pure electric vehicle without having your own garage, you are buying into an external ecosystem.
Wait, phrase that again. I want to make sure I'm grasping this fully. When the renter buys the EV, what are they actually purchasing?
Well, they are effectively being forced to buy a landlord who is actually willing to install chargers. They are buying a local utility company that has upgraded the neighborhood transformers to handle the load.
Oh, wow.
Yeah, they're buying a municipal parking operator that maintains public stations. They're buying a local electrical grid.
So you are basically buying an entire energy system just to get to work.
Exactly. And keep in mind, that is just inside a wealthy, developed city. Now pull back and look at the global market.
Okay, zooming out.
Think about a rural family that relies on one single vehicle to do everything. Commuting, hauling, traveling long distances. Or think about a taxi operator who simply cannot afford to lose 3 hours of revenue waiting around at a congested public charging station in the middle of a shift.
Or like a farmer whose truck absolutely has to run even when the regional power grid goes down during a severe storm.
Right. So the argument is that these buyers aren't just Luddites who hate electric cars. They aren't stubbornly rejecting progress.
No, they are making highly calculated, rational purchases based around their local infrastructure and their personal income constraints. and their tolerance for daily operational risk.
And Toyota, being the largest automaker in the world, is trying to build vehicles for all of those people simultaneously. That is why their strategy can look incredibly slow or even backward if you are sitting in Silicon Valley where the EV infrastructure is highly developed.
Yeah, Silicon Valley lives in a bit of a bubble with that stuff.
They really do. But it looks entirely rational if you are looking at it from the perspective of a global dealership network. A car company of Toyota size does not sell its products into one uniform energy system. It sells into hundreds of thousands of different, highly fragmented energy systems.
Because some countries, like Norway, for example, they have incredibly dense public charging networks and massive government subsidies, so EV adoption just flies off the charts there.
Right, Norway is always the prime example.
But other markets have notoriously weak, unstable electrical grids. They have massive driving distances between cities and zero government help. And honestly, even inside your own city, EV readiness can literally vary street by street.
Which brings us to the underlying genius of the conventional hybrid. Let's break down why it actually works so well for those fragmented markets.
Let's do it.
A conventional hybrid uses a smaller battery and an electric motor to recover the physical energy that is normally lost during braking. It captures that momentum, turns it into electricity, and uses it to assist the gasoline engine.
Right, it's highly efficient.
But the absolute key to its success, the real magic here, is that the driver never, ever has to plug it in.
I love this concept because of what it demands from the consumer, or rather what it doesn't demand. With a hybrid, the customer completely changes the vehicle they are driving, but they do not have to change their surrounding life to accommodate it.
Exactly, it's seamless.
It is an internal transition. The entire technological leap travels strictly inside the vehicle. I mean, it feels exactly like upgrading your smartphone's internal processor.
It's a great way to think about it.
Yeah, you get a vastly faster, better phone, but you aren't forced to personally go out and build your own cellular network just to make a phone call.
The smartphone analogy is incredibly apt here, because the auto industry, much like the tech industry, is deeply obsessed with massive technological breakthroughs. Engineers love paradigm shifts.
Oh, they love a good disruption.
But mass markets overwhelmingly reward convenience. A pure battery EV depends on so many external layers operating flawlessly. You need the municipal grid, the uptime of public chargers, the software connecting the car to the charger, affordable financing for home installations.
It's a massive chain of dependencies.
And when just one of those external layers fails, the buyer feels that entire failure through the machine. And who do they blame? They don't blame the utility company, they blame the car.
Toyota learned this exact lesson decades ago with the original Prius. It became a global phenomenon precisely because it drastically reduced fuel consumption while staying entirely compatible with existing gas stations, existing repair shops, and existing human habits.
But humans hate changing their habits.
Right. But let's elevate this to the corporate level for a minute. Let's look at the sheer financial gravity of automaking, because making cars is a business of enormous, irreversible bets.
People really often underestimate the capital required to build cars at scale. A new vehicle platform costs billions of dollars in research, development, and tooling before a single customer even pays a deposit.
Billions.
Yeah.
Just to design the thing.
Yes. And a massive battery plant has to be financed, permitted, and constructed years before anyone actually knows if consumer demand will be high enough to utilize that factory at its full capacity.
It's a huge gamble.
You are locking in supply chains, you are training thousands of workers, and building complex software teams based entirely on a forecast of what the world might look like 5 years from now.
And the craziest part of this transition is that automakers are currently being forced to pay for two eras at once.
The dual era burden, yeah.
They have to keep pouring money into supporting and running the legacy combustion engine factories while literally building the brand new multi-billion-dollar electric system right next door. It is a massive drain on cash.
It is the ultimate tightrope walk, and it leads directly to the nightmare scenario for any legacy automaker.
What does that nightmare look like?
Well, what happens if EV demand grows just a little bit slower than you forecasted? Let's say you built a factory capable of producing 300,000 EVs a year, but the market only wants 150,000.
That's a disaster.
That new factory doesn't magically become half as expensive to run. The fixed costs remain identical, so your massive overhead is suddenly spread across half as many cars, which completely destroys your profit margin.
Right, and then the inventory just builds up on the dealer lots.
Exactly. And to move the metal, you have to offer huge discounts, When you offer huge discounts, the residual value of the car is already on the road plummets,
Ouch.
which then causes the major leasing companies to absolutely panic and stop financing your vehicles entirely.
So Toyota sat back, watched all of their legacy competitors take that massive existential risk by declaring an all-electric by 2030 strategy. And Toyota chose a totally different path.
They did.
They chose a portfolio management approach. They offer a conventional hybrid for the apartment renter, a plug-in hybrid with 40 miles of range for the suburban commuter, a pure battery EV for the homeowner, where the charging infrastructure already exists, hydrogen fuel cells for niche commercial uses, and hyper-efficient combustion engines for developing regions where the transition is just going to take decades longer.
They covered every single base.
Subscribe to the Unlayered Global now, because this channel does not just explain the headline. It reveals the hidden system underneath it.
But that sprawling portfolio approach raises a massive philosophical question about industrial constraints, specifically battery scarcity.
Let's dig into that.
Right now, battery raw materials, refining capacity, and cell production are all heavily constrained. So Toyota poses this fascinating mathematical question.
Okay, what's the math?
Should the available limited battery material be used to completely eliminate gasoline in one single vehicle? Meaning you put one massive 100 kilowatt-hour battery pack into one EV. Or should that exact same amount of constrained material be used to reduce gasoline use across 50 to 90 different vehicles by manufacturing dozens of smaller hybrid packs?
Because an EV operating on a clean, renewable electrical grid is obviously better for long-term emissions when you look at that one specific car.
Unquestionably.
But Toyota is arguing that progress shouldn't be measured by the creation of one perfect zero-emission car. It should be measured by the total carbon reduction across the entire global fleet of millions of vehicles. They are treating the battery as scarce industrial capital that needs to be deployed for maximum impact, not just like another car part you blindly order from a supplier.
And treating the battery as scarce industrial capital leads us directly into a massive geopolitical shift.
The geopolitics of this are wild.
The EV supply chain is incredibly concentrated, honestly, far more than the oil market ever was. China hasn't just built tremendous strength in assembling the final vehicles, they have systematically captured the entire upstream supply chain.
Let's break that down, because people just hear the word lithium and they think that's the whole story.
Yeah.
What else is in these batteries that creates this geopolitical choke point?
Think of a battery cell's basic architecture. You have the anodes, which act as the negative side of the battery, and those are primarily made of highly refined graphite.
Okay.
Then you have the cathodes, the positive side, which dictate the actual capacity and power, and those require precisely refined lithium, nickel, and cobalt. And then on top of that, you have the complex power electronics routing the high voltage throughout the car.
And China controls the processing.
China dominates the refining and processing of almost all of these elements. It is not just about mining the raw dirt out of the ground. It is about the intense chemical processing required to turn that dirt into battery-grade materials.
It just flips the entire power dynamic of the automotive industry completely on its head. For an entire century, automakers essentially controlled their own destiny because they controlled the engines and the complex transmissions.
Right, the heart of the car.
The hardest, most valuable parts of the car were built entirely in-house. Now, the strategic power shifts way upstream. It shifts away from Detroit and Tokyo and moves to mineral processors, semiconductor firms, and foreign governments.
Energy security hasn't disappeared in the electric age. It has just completely changed form and moved to a totally different continent.
Which brings us to Toyota's $14 billion decision. This is exactly why Toyota is spending nearly $14 billion constructing a massive battery plant in North Carolina.
It is their ultimate hedge against this exact geopolitical risk.
Yeah, when you look at the blueprints for that plant, the sheer scale is impressive, but the flexibility is what actually matters to their corporate strategy.
The flexibility is everything.
That single facility is fundamentally designed to pivot. It can produce batteries for conventional hybrids or for plug-in hybrids or for fully electric vehicles, depending on what the market demands on any given day.
So they aren't throwing $14 billion at one single rigid prediction about what the world will look like in 2032.
Right.
They are investing heavily in the bottleneck itself, the battery supply. They are preserving the choice to rapidly adapt to whichever future actually arrives, rather than forcing a future that might not happen.
Precisely. They invest capital strictly where the technological pathways overlap, They build the core component, and then they sit back and let the customers, the realities of local grid infrastructure and shifting government regulations, dictate how that factory's capacity is ultimately utilized.
It's incredibly smart.
But wait, how do they afford to straddle these two worlds? This brings up, honestly, the most brilliant part of their financial strategy. The hybrids aren't just a bridge for the consumer to get used to electric motors. They are a literal bridge for Toyota's balance sheet.
Oh, absolutely. Hybrids are their absolute financial engine right now.
That's so.
The legacy business of building hybrids and efficient combustion cars is incredibly well understood. Toyota has decades of actuarial and used car data. The dealers know exactly how to sell them.
And the banks know how to value them.
Yes, the massive financial institutions know exactly how to estimate their resale value. So Toyota is taking this highly profitable existing business and using it to actively print cash.
You fund the new stuff.
Exactly. That cash is then used to quietly finance the incredibly expensive, painful transition into software architectures, battery plans, and future EV platforms, all without having to rely on volatile stock prices or taking on massive debt.
Let's bring this macroeconomic theory back down to the household level, to your actual wallet as a listener. Because when you walk into a dealership to buy a car, the sticker price on the window is basically an illusion.
It really is.
Your actual monthly payment depends on interest rates, insurance premiums, and critically, the expected residual value or resale value of the car when you eventually try to get rid of it.
This is where EV depreciation has become a terrifying factor for the average household. Let's just walk through the math on this.
Walk us through it.
You buy a new EV today for $50,000 on a 5-year loan, but battery technology is advancing at a rapid software-like pace.
So what happens in 2 years?
2 years from now, a brand new EV hits the market that offers 100 more miles of range, charges twice as fast, and costs $10,000 less than what you paid.
Which is great for the new buyer, but terrible for you.
Exactly. Suddenly, the older EV you own loses its value incredibly fast. The next buyer gets a vastly better product for less money, but you, the current owner, are the one who has to absorb that massive write-down in value. You find yourself severely upside down on your loan, owing the bank far more than the car is actually worth.
But hybrids carry a totally different set of risks. If you choose to buy a hybrid today, you are avoiding that massive EV depreciation cliff, but you remain fully exposed to wildly fluctuating global gas prices.
Right, you are still buying gas.
You still have to pay for oil changes and complex engine maintenance. And you face the very real risk that future government regulations might ban them from city centers, making them much less attractive down the road.
It is a crucial distinction. You are never choosing between risk and safety. You are simply choosing the type of risk that best fits your life and your personal finances.
Right.
Toyota's massive product range effectively takes all that massive economic and technological uncertainty and converts it into simple market segmentation. They just hand the household a menu and let them choose their preferred operational and financial risk.
All right, I want to challenge this entire narrative now. Let's look at the bear case. Let's explore the massive danger of all this calculated caution.
Okay, let's hear it.
Because there is a very real argument that spreading your engineering resources across all these multiple pathways, combustion, hybrid, plug-in, hydrogen, EV, creates enormous organizational drag.
It absolutely creates massive internal complexity. Just think about the procurement and engineering nightmare involved. You are dealing with multiple different battery chemistries, completely different mechanical platforms, vastly different global suppliers.
Sounds like a headache.
It is. Multiple overlapping software systems and incredibly complex training programs for your mechanics. At a certain point, corporate flexibility devolves into expensive duplication. You just lose the efficiency of scale.
And software is the real battleground where this strategy potentially falls apart. You can't just wait at the edge of a market, watch everyone else figure it out, and then try to buy software leadership later.
No, you really can't.
EVs are no longer just cars with batteries instead of gas tanks. They're rolling digital platforms. Tesla has accumulated years and years of real-world operating data from millions of drivers, constantly refining their self-driving and battery management algorithms.
The data advantage is huge.
And BYD in China has deeply integrated electronics, building everything from the microchips to the seats in-house at massive scale.
And look at how Chinese automakers have completely redefined what a premium car even means to a modern consumer.
How so?
They're defining premium through massive, responsive digital screens, seamless smartphone connectivity, ultra-fast charging speeds, and rapid over-the-air updates that literally improve the car overnight.
The definition of luxury has shifted.
It has. The definition of a luxury car is no longer just about mechanical refinement, tight panel gaps, or how quietly the heavy doors shut. It is about the software experience.
So while Toyota was brilliantly protecting itself from the financial risk of building the wrong battery factory, its competitors were out there in the real world accumulating a massive, potentially insurmountable software and data advantage.
That's the real threat.
But what about the technologies Toyota keeps promising? What about solid-state batteries and hydrogen?
Well, Toyota relies heavily on the promise of solid-state batteries, which theoretically offer a massive leap forward. To understand why, you have to look at a current battery. A standard lithium-ion battery uses a liquid electrolyte to move energy back and forth. Think of it like a liquid moat that the ions have to physically swim across. It takes time, it generates heat, and that liquid is flammable.
Okay, so what does solid-state do?
A solid-state battery replaces that liquid moat with a solid material, a literal bridge. The energy moves incredibly fast, you get vastly faster charging, much better range, and virtually no fire risk.
That sounds like an absolute game changer. Why isn't it the answer to all of this?
Because laboratory promise is vastly different from mass manufacturing reality. Getting a solid-state battery to work flawlessly in a pristine lab is one thing,
Sure.
but manufacturing millions of them a year perfectly at a cost the average consumer can actually afford, and having them survive the brutal reality of potholes, freezing winters, and scorching summers, that is a monumental engineering challenge.
And the exact same logic applies to their hydrogen fuel cell strategy. Pumping hydrogen gas into a car to create electricity makes total sense for heavy commercial transport or long-haul trucking, where massive battery weight is a huge penalty.
Right, for semi-truck it makes sense.
But treating a complex hydrogen network as a mass-market answer for the everyday suburban driver is pure speculation right now. These technologies are incredible future opportunities, but they are not permission to arrive a decade late to the current EV software party.
That's very true. But this internal debate at Toyota also ties deeply into the political power of their strategy, specifically regarding global jobs and the industrial base.
Jobs are a huge piece of this puzzle.
An EV transition fundamentally changes where economic value is created. It drastically shrinks the thousands of traditional manufacturing jobs associated with casting engine blocks and assembling complex gears for transmissions.
And it replaces them with what?
It grows the high-tech jobs associated with software coding and battery chemistry.
But the brutal reality of that shift is that those high-potent new software jobs do not magically appear in the exact same manufacturing towns that just lost the engine jobs.
Yeah.
You cannot simply take an old engine block plant in the Midwest or rural Japan, swap out the sign out front, hand the workers a laptop, and call it a battery factory. The disruption to the workforce is incredibly violent.
So Toyota's slower multi-pathway approach actually serves to protect the existing industrial manufacturing system and its millions of workers for a much longer period. They are softening the blow.
That makes a lot of sense politically.
If you are a loyalist or a supporter of Toyota, you look at that slow transition and you call it vital economic stability. But, if you are a climate critic or a tech investor, you call it intentional, dangerous delay.
So if their strategy makes this much economic and social sense, why are governments fighting them so hard on this? This brings us to the policy loop. Governments around the world are actively trying to force this transition, regardless of Toyota's pace.
They really are pushing hard.
Europe is forcing the issue with incredibly strict, unyielding emissions targets. The U.S. is utilizing a complex mix of massive consumer incentives and heavy tariffs.
And China.
China simply bypassed the debate entirely and built a massive integrated supply and export system from the ground up, heavily backed by state capital.
Governments try to force the transition through aggressive mandates because they want to spur the creation of infrastructure. It is a classic chicken and egg problem.
Right.
They believe that if they force the automakers to build millions of EVs, the utility companies and private charging networks will be forced to build the grid to actually support them. But Toyota pushes back against this logic, fiercely arguing that government targets have to match physical engineering reality.
Because if a government aggressively mandates that every new car must be an EV, but they fail to actually upgrade the neighborhood electrical transformers to handle the massive new load, or they fail to ensure that affordable, safe charging access actually exists for lower-income households in dense cities, the government isn't actually solving the emissions problem.
No, they aren't.
They're just shifting the massive cost and inconvenience of the transition directly onto the shoulders of the consumer. The local municipal electrical grid is now essentially an unlisted, wildly unpredictable part of the car you just bought.
So when you pull all of this together, we are looking at two very distinct, polarizing futures for Toyota. Let's outline the bull case first.
What is the bull case?
The bull case for Toyota is that this global transition remains incredibly messy and fragmented for the next decade. The public charging infrastructure continually lags behind, local power grids struggle to handle the load, and EV adoption just plateaus.
And in that scenario?
In that scenario, Toyota smoothly and profitably scales up their own EV production later in the decade, utilizing the massive piles of cash they generated from their globally dominant hybrid business. And they do it all without having suffered through years of idle EV factory losses and brutal price wars.
That sounds great for them, but the bear case is absolutely terrifying.
What is the bear case?
In the bear case, battery material prices absolutely plummet globally. Ultra-fast public charging becomes as ordinary, reliable, and widespread as gas stations. Software and digital connectivity become the only things new car buyers actually care about.
That changes everything.
In that scenario, Toyota wakes up and finds that its highly profitable, cautious middle path has suddenly become way too narrow, and they are forced to play a desperate, incredibly expensive game of catch-up against tech companies that are 10 years ahead of them in data collection.
Yeah, Toyota's ultimate existential test is whether a sprawling legacy corporation can accurately read hundreds of different local, neighborhood-by-neighborhood energy transitions without losing the massive global scale that makes them profitable in the first place.
It's a huge balancing act.
Because buying yourself time with the hybrid strategy is only a useful asset if you actually use that time to convert cash into future digital capability.
Exactly. Toyota deliberately avoided placing its entire massive balance sheet behind one single forecast just to protect itself from ruin. But here's a final thought for you to mull over as you watch those millions of cars on the morning commute. In the end, when the global infrastructure finally catches up and the world truly becomes ready for electric vehicles at massive scale, will Toyota's incredible patience look like historic, brilliant foresight? Or will they discover the hard way that the future simply does not wait for the most careful company in the room?
That is the multi-billion-dollar question.
Subscribe to the Unlayered Global now, because this channel does not just explain the headline, it reveals the hidden system underneath it.